We're waiting on Dario now, yeah?
Yes, sir. That was with confidence interval and stuff and sexual material.
Yeah. And yeah, but some of the conditions that we did so far now.
The conditions. That's with like
But
non-normal.
yeah, if it's normal and the variance given and so on.
You do non non-normal, um unknown, sigma squared and large sample size. You do normal, known, sigma squared and
Oh, I did all that.
yeah, you do
Oh,
three.
okay. So the first one I did, and remember that they all followed this particular pattern, right? So X bar, that's the sample mean, minus whatever probability that they give you, 1.96. If they give you a sigma, if they give you the standard deviation, out over the square root of n, right? And then X bar, that's the upper limit, plus 1.96, right? Sigma on the root 10. Question. 1.96 represents what percentage confidence interval? Anybody remember? 1.96 is what? 95%, right? Remember, I gave you all the values, right? I gave you the three popular ones, 90, 95, 99. Right? So based on the confidence interval, based on that percentage, right? This value here would change. Okay? Right. What does happen if if it's a normal population that the sample came from, and you know the variance, and is any sample size, large or small, then this is the formula we're using. Right? That's the first condition that we did. The second condition that we did is that if it's non-normal, so it's not normal, right? The variance is known, so we can find sigma, of course, and the sample size is large. So what you do, I change the color, right? What you do when n is more than 30 and it's non-normal. And it's non-normal. I pick on somebody. Let us pick Kaylin. What you do if the sample size is more than 30, the distribution is non-normal. What you do? Kaylin? What do you do? So I don't know. I wasn't here last class and I'm not paying attention right now. And I did not watch your video. Okay, I read all of that. Right? So Amber. Where Amber going? Amber, what you do if it's not normal and the sample size bigger than 30? Bradley, get ready, yeah? You should answer.
No.
Standardized, no killing. You should have been watching the video anyway. Tomorrow. Yeah, Amber, what you do? Amber not paying attention, all right. I will message Miss Raghu there. Bradley, calls to you, Bradley. What do you do when n is more than 30 and it's non-normal?
You gotta use the formula, see?
Use the formula.
The C formula from what you gave us last class. I think.
No, that's not what it is do. not normal. Remember variance known, eh? Right? Let me make a note of that as well. Variance known. Who we can pick on here? Let me pick on Ramsarup, Mr. Ramsarup. Talk to me, Mr. Ramsarup. What do we do? Mr. Ramsarup, very good. He said use central limit theorem. Very good, Ramsarup. So you use central limit theorem and then you go back and use the same formula. So the formula not changing. Same formula. Same formula. All you have to do is state by central limit theorem. We're using it as a normal. Right? So even if it's non-normal, it's like you're approximating it. We're approximating it by central limit theorem for a normal because the sample size is so large. And the last one, not last one in terms of what we did last day. Suppose is from a normal. It could be non-normal as well. And large sample size, but it is an unknown variance. How will the formula change? Let's pick on Darian. Darian again, thing I checked. Darian, what you'll do in the third case?
And theaters use the same central limit theorem.
No, that is different non-normal. Suppose it's normal and bigger than 30, but you don't know the variance. What you do?
I'm not too sure, sir.
Or what is the problem right now? And you don't know the variance,
Yeah.
so we're finding variance.
Oh,
yeah.
well, they use NPQ.
So you have to estimate the variance. No, the long formula, the one I gave you last 2
Oh,
weeks.
that one. Okay, okay.
Right? So you have to estimate the formula. So the formula stays the same as the one in black, except you will have a little pattern surface stigma because they estimated. All right? Right? And as Ramsarup said, if the distribution is not normal, bigger than 30, unknown variance, central limit theorem, and use the formula to estimate unknown variance. All right? Right. So that's where we stopped last day. And today we have one more condition to look at, right? But I don't think I got to do any past papers on those days. So I'm gonna just look and see if I can find one here for you. Hold on. Right, I want you to notice that the formula staying the same. All that changes is the 1.96. Right, regardless of the condition, that's all that will change in the first 1, 2, and 3. Okay, so I want you to remember it's the same form, right? Let's give me 1 second. Huh? All right, let's try 2021. Try this here. Use your formulas and estimate mean and standard deviation. Tell me what you get. When you get your values messages, please. For the mean and standard deviation, right? Any answers? I only have one so far, Jesse answer. Right, we'll got both of them. Then we'll go to the next part together, right? Right, after this, we'll do the T distribution. Right, so you should have your X bar value. Right, your X bar value is the sum of X on N. So that'll be 1600 over 150. I've got calculator today, so I'll do it. Right, so I got 32 on 3, or like 10.66, right? And then they want standard deviation, so I'll work out the variance first. Right, I'll work out the variance first. So that's 1 over n minus 1 by the summation of x squared minus the summation of x all squared all on n. Right, so that's 1 over 150 minus 1, Sum of x squared is 18,040. Sum of x is 1,600 all over, sorry, 1,600 squared all over 150. Right, what y'all got? I see in, what's that killing? Oh, looking kind of big. What y'all got there? Remember, there's a next version as well, eh? It have more than one version. You see? Right? Remember, it have more than one version, right? Where was I? 1,600 squared all over 150. So I put it all in the calculator and I got 6.53. Okay? So remember that's a sigma hat squared, right? Question asks for standard deviation. So that'll be the square root of that. So square root of 6.532. That's 2.56. Okay, so that's the value we use it. Right, next one. State an appropriate distribution for the sample mean. So go back to your sample mean, and you should remember this X bar follows the normal distribution, mean mu, variance, sigma squared on n. Right? So your answer will be X bar, normal, right? The mean is 3213, and the variance is 6.53 over 150. Right? Question did say it follows on normal, so we do have to say by central limit theorem, right? Everybody okay with that so far? Bradley, you not send anything, buddy? Oh yeah, you
Son, your man, sir.
you send something. You actually send something. Not you all put into Darian.
Bye.
Darian and send nothing. Nice, Bradley. Nice. You send something, Bradley. Right. Now they want a 95% confidence interval for the unknown population mean. Right? So all they want is the same confidence interval. We already estimated the mean, the variance. So we got to go. Work it out, tell me what you get, please. 95%, so you know that value, right? Right, work it out, message what you got, right? Who will send anything as yet? Ravisha. Excuse Ravisha, you can send one answer for the class, please. Work out this now. That's one answer. Right, that's all I asked. Let me start with one. Next week we will try for two. Oh no, I didn't see that. Send this one. Send something that count. Send that part 3 there, come on. Nice, values coming in already. Nice, nice, nice. Nice, nice, nice. When Revisha send ours, Thursday good to go. Wonder if Darian sent anything, but wait, now people missing, I know we like Jalen and oh gosh. Right, values coming in. Sir, I looking for my calculator. That's why I can't answer. Okay, Darian. All right, Darian. So you don't need a calculator. Your mic working. Tell me what to write. What to write to work it out here. You just tell me, and I will do the calculator work for you. Can I find your mic? Mic not working?
Nah, sir, is X bar minus 1.96
Why is
times
1.96?
because the confidence interval is 95%.
Nice.
And then using sigma all over the root n.
And then you plug in
You have
bar
plus 2.
and
And then
nice. Good. So X bar is what? Darian, what is X bar?
but sir, look at and write it.
Well, I probably write the wrong thing.
Nah, that's the correct.
Correct thing, all right. Right? So we have our segment that we estimate down here. We have N and we have everything that we need, right? So when you work it out, I will go with two answer here. Bradley sent me something. 10.26 and 11.08. That's okay? All right, nice. Everybody okay with that? So that's the way you handle questions like this. Now let's go to a new distribution called it T distribution. Right? Revisha. Hey, look, Revisha, somebody give Revisha the answer. Good job, Revisha. Ramsarup, your value looking a little different to mine's. Right? Just check it and see. I use Bradley value, by the way. 10.26, 11.08. Unless Bradley sent it to Revisha, that could have happened now. Kaylin get this too. Right? Ramsarup and Jesse, just check back all the values there. Looking a little different. It close, right? Always remember your X bar value should lie in between there, right? Okay, nice. So that's a confidence interval. I'm not sure if I mentioned it last week, but if you have to find the width of the confidence interval, you can minus those two values. Okay? There are also some questions that don't really come like this again, but like in the older years, they would give you 10.26 and 11.08 and ask you to find n. So you have to take 10.26. So you're going to take this here, plug in everything you know, and make n the subject of the formula. So sometimes they could ask you to go the other way around. Okay? So same principle, but sometimes they just ask you to go the other way around and find the n value and so on. All right. So today, our objective is to understand a new distribution. What just happened there? To understand a new distribution called the t distribution. Hold on, my screen. Sorry, what just happened there? Hold on, How do I remove that? You cannot start sharing while you collaborate on board. How to remove this? Oh, my God. What you'll see now? What you'll see now, the whiteboard or the old screen? The original whiteboard, right?
Whiteboard, yeah.
Okay. All right. So let's talk about this t distribution, right? So this t distribution is technically a normal distribution when the n value is real small, right? Hold on, chi-square t, right? So look at it there. That t distribution pretty much is just like the normal distribution, right? It's just like a normal distribution, but you'll recognize that a normal distribution is a little bit bigger, right? And it caters for a lot more values. When your n values are a little bit smaller, right? When your n values are a little bit smaller, we use a distribution called the t distribution, right? So for example, when n is less than or equal to 30, less than 30, it no longer follows a normal distribution. It now follows a distribution called a t distribution. Okay, and that's the t distribution there. And to standardize their values, it's like how you used to standardize z, which is x bar minus mu all over sigma root n. Same thing. T is equal to x bar minus mu. T is equal to x bar, right, minus mu all over sigma hat on root n. The reason why it's sigma hat is that whenever you have a population that is normal, your sample size is small, that's less than 30, right? And sigma squared is unknown, means that you don't know it, right? We use a distribution called the t distribution. Okay? And as I said, the t distribution looks very similar to the normal distribution, right? But the problem with the t distribution, to get the values, right? To get the values, we need two things. We need to know the degrees of freedom. It's called the degrees of freedom. That's basically if n is 10, the degrees of freedom 10 minus 1. So if your sample size is 10, 10 minus 1 is the degrees of freedom. Okay? So it's n minus 1 degrees of freedom. And of course, you have to know what percentage you're reading off, right? So let's take a small example of how to actually use this distribution, right? Write down the conditions, please, to use the t distribution. All right, I'm gonna write in red now, right? So suppose I gave you an example. I say, well, here's what. Find the probability of t less than right? You'll see that? Hold on, eh? I just want to make sure we're on the same screen. I find my iPad keep crashing there. Well, what you're seeing now?
The distribution table and probability at t less than.
Right, you see any writing in red?
Yeah.
Okay, nice. Okay, nice. So let's see if we can find the t value, right? We're using a degrees of freedom. The symbols that are used for degrees of freedom is V. Let's use degrees of freedom V as 14, right? And degrees of freedom P as 14, and let's read off 0.90, right? Or a 90%. Okay, so 90% corresponds to 0.9, right? 90% corresponds to 0.9. So we're looking at this column here, 0.9. How far you'll see? All right, sorry. Let me just change from 40 to something small like 9, right? Because I now realize you're not seeing 14 there. But look at 9. So you're looking for 9 degrees of freedom, 0.9, and you get 1.383. So here what that's saying. That is saying that for 1.383, right? This probability here, right? This probability here, when the degrees of freedom is 9, is equal to 90%, or 0.9. You're okay with that? You're okay with that? So just to show you how to read it. Right? Let me give you our next one to read. Right? See if we can reread this one. For 6 degrees of freedom, find the probability of t is less than some value. That gives you 99%, 0.99. What you all getting there? Oh, by the way, it's less than, which is the same thing like in normal distribution, the less than part that's being shaded, right? Right? So you should have 6.99, 3.1, 3.143. Okay? Nice. I just got to play, so I'll give you one more. I'm gonna clear it out, give you one more. Right, suppose I change it like this now. Suppose I said, what's the probability of t is less than 1.796? What's the probability of t is less than 1.796? Right. At 11 degrees of freedom. Probability of T is less than 1.796. 11 degrees of freedom. Right, so take your time, look for 11 degrees of freedom. You're looking in that row, 1.96. So the probability is 0.95. Nice. Okay, so what do you think will be the probability of T is more than 1.796? That's, of course, that'll be this shaded region here. What will that be? One minus, very good. So it will be 1 minus 0.1 minus 0.95, so you'll get 0.05. Okay, so it's very similar to how you read off the normal, because it's also a symmetrical curve. Any questions on how to read the T distribution? Any questions? Because I want to bust up the period now. Any questions? Bishop, any questions? Bradley? Amber, any questions?
No, sir.
Okay. All right, so here's what I'm going to do now. Remember, when we had to get the confidence interval, right? Remember, we needed like a 95% confidence interval, right? We had to read off a particular value here for us to get the 1.96, right? So I want the same thing. I want to do a 95% confidence interval, right? Using this T distribution. So I want you now to figure out what those values will be. Of course, I'll have to give you I will have to give you a particular degrees of freedom, right? Right, let's be specific. Let's see, degrees of freedom is so now we can get there. Degrees of freedom is 7. I want a 95% confidence interval. See if you can find those values here for me. Right, just like how we got the 1.96 last week. Let's see if you can find those values there. Be careful, eh? Remember, inside here is 95%. Oh. Right, as I said, 7 degrees of freedom, right? But you all got. So you would have recognized, right, that if this is 95%, that the piece in the middle, then outside here will be, outside here and here will be half of 5%, right? So that'll be 2.5%, 2.5%. So what that means for us to get this value, this entire probability here would be 0.975 or 97.5%, right? So now we have to figure out what that t value will be. So you're looking for 0.975, right, on top, and you're looking for 7 degrees of freedom. So that will coincide right here. Right, that'll coincide right there, 2.365. 2.365. Right? So the value here, 2.365. So of course, we're doing the same thing, eh? We're doing the same thing, right? So we're going to get wherever x bar is minus 2.3, what did I say again? 2.365 by sigma hat all over root 10, right? And then plus it. Any questions? So how you get 0 point, right? Okay, I join it back here for you in blue. Remember, a 95% confidence interval means that here represents 0.95%, right? Or probability of 0.95. So these two cutoff boundaries, because it's symmetrical, will split the remaining 5. So here we'll have 2.5% or 0.025, and here we'll have 0.025. Okay, so if I had to read this value, everything to the right is 0.025. So everything to the left here is 1 minus 0.025, which is 0.975. Right? So this is the value that I have to read off from the t distribution. Right? So I read off 0.975 at 7 degrees freedom. That's okay? Darian, you okay with that?
Yes, sir.
All right. And that's all you need for the t distribution. Right? Everybody have this table to use, right? All right. So in case you do have it, just screenshot it. I am going to give you one too. Right? How do you know that you have to use a t distribution? Simply, you recognize you have to estimate sigma and n is small. All right. Anybody have questions? Ask now, right? Because I want to give you one. Of course, you don't have to figure out what this one is, right? Only some little textbook, right? I'll look for a past paper, this one. Everybody ready? Take your time and try this one, right? Take your time. Right? How do we know the t distribution here? Bradley, how we know we're using the t distribution here?
But it didn't say, they didn't give us the variance.
Huh?
They didn't give us the variance.
And,
It's on non-normal.
no, it's normal.
Yeah, normal, sorry.
And something else,
Um,
and it's small.
yeah, and it's small.
Okay, so just checking your values out. For X bar, I have 397.87. For sigma hat, I have 3.213. Anybody got that? Of course, n is 1, 2, 3, 4, 5, 10. Right? It's a 95% confidence interval. Right? So I need the probability of t is less than, well, mod t is less than t is 0.95, and the degrees of freedom will be 9. Anybody have those values for sigma and anybody have those values, sigma? So what formula you use for variance? Same formula, 1 over n minus 1. Same one I used just now. I got 10.325. What you got? What you got for sigma squared? A negative? Nah, that's impossible. Alright, let me check and see. So remember, sigma hat squared will be 1 over 10 minus 1 by what they give it in 1, 5, 8, 3, 0, 9, 8.3 minus 397, 8.8 all squared over 10. Tell me where you get it. The value I have here is 10.325. You figure it out now. When you work out that, what you all got for this all, yeah? That is all your answers now. I gain 1 point, probably error then. I gain 1.484. I gain 1.484. Yeah. Right, so we gotta change it then. So I am getting 1.484, and square root of 1.484 is 1.218. Right? 1.218. Maybe they made a mistake. That is a big standard deviation anyway. Okay, yeah, Jesse, what you saying now? So don't you have to square the entire or just a different formula? No, that's a different version. I think that's the one with the n over n plus 1, n minus 1. That's where you square the entire right hand side. I am using the 1 over n minus 1. Yeah, you getting that? Okay, yeah. So you probably have error here. Right? So we go in with 1.218. Okay, so now we're going to get it confidence interval at 95%. Right? So remember, same thing, x bar plus and minus, but whatever that t value is, we're going to get by sigma hat on root 10. Right? That x bar value was 397.87 plus and minus. What y'all got for the t value? Remember, it's 9 degrees of freedom and you're reading off 0.975. I close up my table. 0.975, 9 degrees of freedom, I got 2.262. 2.262. Right, the sigma hat that we're using is 1.218 over the square root of 10. Anybody get that? Anybody get 2.262? That's the most important thing, huh?
So how we does know like when it's symmetric? Because sometimes in questions I see it behave like a one tail. So you don't have to like divide by 2.
No, confidence interval is always symmetric. I think you're talking about hypothesis testing,
Oh, okay.
right? Right? So confidence intervals is an interval, so it's always a left and a right that's symmetric.
Okay.
When you're talking about hypothesis testing, when you have upper tail and lower tail, right? That's when it's one side alone. But confidence interval, same thing all the time.
Okay.
When we do hypothesis testing next week, then you'll see all. Right? How much is this? What you all got for the 1.218? What you all got there? Anybody have values there? Jesse have 397.01 and 398.75. Anybody else get that? Right, so I have those two there. Yeah, it's similar to what you have there, Caleb. All right, so that's the way you work it out. The hardest thing here, well, besides trying to make sure we all get the same sigma value. Ramsu, are you okay? Ravisha? Right? The hardest thing is to remember how to get t value. Okay? All right, we do have time to do our next one, but here's how I do for now. I want to change it up a little bit. Right? You're not going to work out anything. All I want to get is the t value. So tell me for 14 degrees freedom. For 14 degrees freedom, do a 90% confidence interval for me. All I want is t value, 14, 1, 4. Do a 90% confidence interval. You just messaging me the t value. Everybody in the class, everybody. From Ravisha all the way up to Amber. Everybody. Yes, Darian, that is same thing. That's what I got. This one here. That's what I got. Right, so work out for 14 degrees of freedom, 90% confidence interval. Find the t value for me. What's the t value down over here? Plus and minus t sigma hat on root 10. I want to know what that t value is. 90%, right? I have one answer. I want to see 8 answers or 7. Mark, how much I've already. I have one answer so far. Message me alone, eh? Me alone. Ramsu, check it back. Remember, it's 90%, right? Here is 90%. So try to figure out what's here and here, and then you will figure out what value you're looking at. Bradley, check back yours. Bradley, how it could be the same thing as 90%?
Oh wait, okay, sorry.
Check it back. 90%, 14 degrees of freedom. 1, 4. Ravisha answers. Amber. Jesse, Olive. Hurry up. Right. Ravisha, correct. Ramsu, correct. Jesse, correct. Waiting on Amber. I message Amber mother. Amber is not responding. Bradley, how you get that, Bradley? Check it back one more time, Bradley. So how much is here, Bradley? What's the value on either side if the middle is 90%?
It'll be like 294 and 401. That's all I got.
No. No. If this probability, if they want a 90% confidence interval, right? The piece in the middle is 90, right?
Yeah.
So on either side is how much? It's symmetrical. Either side is what? 10 divided by 2, right? Either side is
Yeah.
Either side is 5. So the value you have to read off for is 0.95. If here is 5%, how much is all of this?
95.
95. So you have to read off 0.95. You have to read off 0.95 at 14 degrees of freedom. Okay? And when you go to your table, you should get 1.761. That's okay? Right, Amber? You're not reading out 0.9, you're reading out 0.95. Okay, everybody okay with it? Amber? Bradley?
Yes, sir.
Alright, so that's the way you use the T. Next week, I'll give you a random confidence interval and you have to figure out how to, you have to figure out how to, which of the 4 techniques we're going to use, right? And then we do confidence and then we do hypothesis testing. I think I'll introduce hypothesis testing by doing chi-squared first. So you'll understand the concept of a hypothesis test, and then we will do the other type, the Z and the T and thing. Right? So that's all left for us to do. We have an example, a question to do, and then we have some T distributions to do. Sorry, some hypothesis testing to do. And that's it, right? Those who have my SPA, don't forget to send it. I need Tyler. Tyler not coming to class.